settings has sort of a set session of its own. And so the decision between using your own audio sessions or using AudioKit's sessions is something I'm really interested in at some point discussing, like the threading model maybe, or some hiccups with it, or some, I know that for a lot of the example code, for example, the suggestion is, oh, hey, Matt, so this, for a lot of the AVAudioSession suggestions, or for the AudioKit suggestions, you basically create the engine at the start and you set the category and mode at some point, and then you're like, okay, let's not touch that for the rest of the file. But thinking about sort of how long an object lasts and the threading model is something I still haven't found great resources on.
Yeah, so we could talk about that some here. Share my screen. So are you guys seeing my my screen with Xcode here?
Yeah, you're good.
Okay. So yeah, in AudioKit 4 was we built our own. It was a singleton. So AudioKit itself was a singleton, a shared instance, and we had inside of that an AV audio engine, and we would know at any moment if you're using AudioKit, you had to be using that single instance of AudioKit, and so we had a settings class associated with that basically managed a lot about the session for you. That was a bad model for a variety of reasons, especially AUv3, because you'd have this singleton and you weren't able to have multiple instances of the same thing without playing some dirty tricks. And so we moved away from that. You have to create your own engine now and stuff. But we still have the settings class like kind of laying around, and I'm not sure that it should be there at all anymore, frankly. It kind of advertises that it handles some things, and so I've been slowly deprecating it so that you kind of forcing everyone to figure out how to use AVAudioSession. The idea here being that AudioKit 5 should be a lot like using AVAudioEngine. If you use AVAudioEngine, you're using AVAudioSession and figuring out all the ins and outs of your own app's life cycles without AudioKit making any assumptions for you. So that's kind of like a bit of my it's a bit of me saying like you're on your own in a sense, but we could look at what inside of like AudioKit we still sort of proclaim that we do for you. Some of these things like setting haptics and like this thing, disable AVAudioSession category management. That was what we used to have for just like stopping AudioKit from doing too much. And now all it seems to do is stop this set session function from happening if you have it set. So, I would like to actually work with someone who's got a project that depends on this stuff and, change AudioKit 5 as necessary or add in the helper functions that could make life with AVAudioSession easier without trying to make assumptions about what to do for you. But yeah, most of our stuff that has to do with AVAudioSession is still in the settings class. So it's probably an okay place to look at first, but I don't know it's a good place to rely on the code, because like I said, I do want to like kind of get rid of most of the stuff if I could.
Yeah, I've been spending most of today reading this file, so.
Okay. Yeah, I'm sorry.
No, not a problem. It's that AVAudioSession itself, is one of those tricky things where there's not really a great way to, with the simulator, do anything that gives you any information that'll happen on the phone. And it's obviously a singleton, and there's so many small ins and outs that come from the category, the mode, and the errors there can be really obscure. So
yeah, we left, I think, one of the reasons I think it was okay to have this as a singleton is the idea that you're on a piece of hardware, and that piece of hardware is not going to change from AVAudioEngine to AVAudioEngine. So it should be okay to keep settings as a shared instance, but maybe we shouldn't. Maybe we should either have a settings class be associated with our engine class or our audio engine class, or, my tendency will be to try to, go more and more hands off and maybe give examples for how to use AVAudioSession with AudioKit rather than trying to make AudioKit work magically and figure out what you're going to need and, you know, that sort of thing.
Totally.
So
I think it lives as its own problem, and I wonder how best to kind of start having discussions around AV audio session with the community, so that there's like ways in which the ways that people use it. There's a way that WebRTC has built a whole bunch of wrappers around AV audio session. There's a way that Juice has had their own wrappers around AV audio session. So there's a lot of different modules that seem to wrap AV audio session, and so that seems to almost be its own set of, like, almost outside of AV Audio Engine, its own set of related but not quite under that same umbrella issues.
Yeah, I guess I'm personally not that opinionated as to what it gets wrong. And maybe if I did a project in which it became more of a hassle, I would like know what to do. But at this point, I don't know that I know what I'd want to do in my wrapper. Like I knew what I wanted out of AudioKit. I wanted like some processing and generation and all these effects. But as far as like making the experience of working with Apple hardware better, I don't know that I have a strong opinion on how this thing could be architected. But that doesn't mean it shouldn't be done. It just means maybe I need some other people to you know, take the lead or at least express a lot of interest in it for it to happen.
I can say that I wrestled with this class at one point, trying to figure out how to make it so that I could not cut off the audio from Spotify or Apple Music while playing my AudioKit app. And I actually could never figure out this issue, because I think I could figure out how to make it work if the microphone wasn't enabled. And then at that point, it was like all bets were off and I could never resolve the issue. But I was working on like visualizers and I wanted to just set my phone down, play Spotify, and have my phone give me some cool like microphone enabled visualizer. So yeah, I have a little bit of interest in that. If we could figure out that workflow, I've got some project ideas.
Yeah, we tried to address some of the microphone issues with AudioKit 5.2. Like there used to be an AK microphone that could get started, and that was, it seemed like every time we made a change, somebody would complain, and we change it back, and then we like it just kept on going back and forth. And I think Jeff in Slack called it like the never-ending story with microphones, because there's always a problem. So here, at least now in AudioKit 5, we have the input device as a property on the engine, and so it should be able to be managed through that. Maybe it's still, there's still some details to it, because I know Matt with Pfeiffer was saying like, oh yeah, reminding me that you have to do some of your session stuff like after the audio engine was started or before something. I always forget. Maybe Matt, you remember, but
I think it was like setting certain settings before before creating your microphone. It was like you had to do the settings before the microphone and then start AudioKit.
So if iOS allowed the microphone to be on while other apps are generating audio, it seems like that would be a kind of a privacy issue.
Yeah, I wonder if that's just something that you can't do. Like that is literally hardware related, or you know, like
if I were designing the device, I wouldn't allow it.
They have a mix with others, sort of as an option for the AV audio session. So there is some way in which they allow different apps to mix audio together. Like if you have Google Maps open and you're driving somewhere.
But the key difference here is that the microphone is enabled.
Yeah.
I think even with play and record, you can mix with others.
I can say I would be very interested if anyone's got it to work, because I couldn't get it to work. And I'm just hearing you talk about it, Taylor, I'm thinking there really might be a design intent to not allow that ever.
Yeah, I don't know. I'm just guessing. I got, my app does audio input, and I guess I've never cared. But yeah, I think it does. Well, it does run in the background. I don't know. Shit.
Because like I want to be able to play music from something else and still create visualizations. And since I can't actually access like any audio streams that I don't create myself on the device, it limits you, you know? And so if you want to create a visualizer, well, you can't be playing the music on the same device. And so this presents a problem. Because ideally I would love to just do all that in one. But anyway, I'm taking us on a tangent, so I don't mean to take us away.
No, that's a key point. I feel your pain because I have a lot of visualizer ideas too. And just the idea that I have to put a microphone on my device and listen to some other device. It's just the stupidest thing in the world. So, and it's been that way forever. So I don't know why.
So are there any other questions? Otherwise, we might want to talk about the changes to a dynamic oscillator. Since we left it in a certain state and since then it's changed. Are we good? Seems like it. So I have actually not taken a look at these changes yet, Taylor, either. So this will be new to me. I can drive if you want to talk about it. I think I pulled them down though.
Okay, cool. Yeah, when I was talking with who was I talking with? Matt Pfeiffer about what he wanted out of this, which one of the problems with the previous implementation that we covered last time in office hours was that it was using a queue for these changes to your wavetable. And what that meant is that your main thread could kind of keep sending stuff over, and it would take the audio thread a while to catch up to consume all that. And you could have the audio thread just consume everything that's in the queue to kind of catch up each time. There's kind of no point in doing that. You can just use a single atomic. So we still have our like wavetable info, and you can still see on line 23 we've got our atomic, which says like when the audio thread is no longer needs the wavetable. But then down here, instead of a queue on line 40, we've got just an atomic, and we can just set that pointer atomically so that the audio thread picks it up. So like, let's see, down here in send wavetable, that's when we're sending it across to the audio thread. And on line 81 there, you can see we just, we've created our info and we just assign it. And we still have to put it in the old tables array, because that's going to do our garbage collection basically. So the key thing there, if we go to collect tables, that's up here. Yeah. Now the key realization is as soon as you've seen one that is done, that the audio thread is marked as finished, and you know that anything that was older than that can also be deleted. So that way you can just bulk delete a bunch of stuff if the main thread was sending a bunch of stuff over faster than the audio thread can see it all. So audio thread doesn't need to see every single table. Eventually it's going to see one, it's going to use that for a while, and it's going to mark it as done, and then it'll clean up the rest. Now it may be a little time before that actually happens. But the assumption here, I guess, is that you're not sending like so much wavetable data that you're going to run out of memory before this gets deallocated. So yeah.
It does look like it's getting progressively simpler from using TP circular buffer down to this.
Yeah, definitely. I mean, this is type safe. TP circular buffer involves some ugly casting, which brings me to another change if we want to go look at it, or we can.
Yeah, I definitely wanted to look at that. You're talking about the sequencer engine?
Yeah.
Can I just ask a question before we move on? So
Absolutely.
where is, the garbage collection of the atomic pointers, it makes sense, it's super clean, it's cool. Where is the table actually being allocated, and where is that pointer pointing to it? So is that table being allocated in the Swift layer in the main thread?
No, it's allocated down there in send wavetable.
Okay.
Down a little bit, line 76 right there.
Okay.
It creates the wavetable info, and it creates a sound pipe F table.
And all of this,
copies the data in there, so everything's ready to go.
okay, but the main thread is calling this in our use case.
Yes,
right?
absolutely. This is not to be called an audio thread. This is all
Got
main
it.
thread.
Okay,
Um,
okay.
The
Thank you.
reason why
That
there's
makes
the
sense.
send wavetable, I mean, this is kind of minutia, but one of the things about the life cycle of this is that the whole sound pipe stuff isn't actually set up when set wavetable is called for the first time. So we just kind of store it in initial wavetable, and then we end up using that initial wavetable in it. So
Yeah,
I'm not in love with the life cycle of this stuff, really. Like, I prefer it to like once it's constructed, it's in a completely valid state, you know, as soon as it's constructed. That's always a nice property to have.
and it refresh my memory, the sound pipe object is at the like a global level above all of these oscillators, or is it per, you know, for example,
It creates a sound pipe state object in the DSP base.
in the DSP base? Okay, got it.
Yeah.
That makes
So
sense.
it's not like a global variable or anything.
Yeah, okay, so each one of the DSP bases or sound pipe DSP bases has. And what do you guys like to call it? What's the language for the sound? You call it sound pipe state? What do you call it?
Sorry, what?
What do you guys are calling naming? Like, you called it sound pipe state, the SP?
Oh, yeah, whatever it calls it.
I don't know. What I was just
What's
curious
the-
what the vernacular is, because you
what
use
is
it
it?
everywhere.
I think it's SP data or something like
SP
that.
SP data. Okay.
Oh, yeah.
I mean,
Okay.
Paul just calls it. Yeah, SP data is
Okay.
SP. Yeah.
Okay. Cool.
Yeah, that's
Cool.
yeah, sound pipe, and that's where you tell sound pipe what the sample rate and other stuff.
All that.
You know?
Got it.
Thanks.
Thanks.
Yeah. I kind of prefer the way like STK, the synthesis toolkit, does it. I guess you just set the every DSP object, you tell it what the sample rate is, you know, because really it's not like you really need to keep that data in one central place. You know, you can just put it in each object.
Let's see if that's clear here somewhere, but
Yeah, I don't know. I don't remember exactly where it is, but if you walk up the hierarchy, you'll find it like DSP base probably. Line 5, if you right click on DSP base. Not that DSP base.
okay, line 5. This one.
Yeah. So, is that still our? Oh, I mean, actually look in STK. We're not even looking in STK.
Oh, in the actual STK. Okay.
Yeah.
Where is this thing?
And I don't mean SDK. I mean STK.
I do too.
Okay. Good.
Yeah. One of these. I'm not.
Yeah. Look in the header.
Oh, maybe just the headers for all this stuff.
No.
This one. No, that's when we were at.
Yeah. Go back to STK.
Yeah.
Open include, and then it's probably called like, I don't know. Just like click on like any of these, and you'll see what the base class is, and then go to the base class. It's just called STK. And say set sample rate. So like any of these little guys just has a sample rate on it, and probably has a few other things.
Yeah.
Does that have a setter and a getter for that?
Does.
Okay. So it still is like dynamically changeable if you
Well,
do
actually, look at this. This is actually a static. The sample rate is static. So what I'm saying is wrong. It's a static value. So yeah.
So don't look at this for the best way to get.
Never mind.
STK is pretty old, yeah.
Yeah.
All right, well, let's look at sequencer engine because that's the other thing that changed this week. All right. So this not, I guess this didn't change at all. It's all inside the MM file.
Yeah, and that was Matt Howell suggested to use this other queue, which seems pretty good. It's certainly better than circular buffer, I would say. It's just ergonomically, like if you see that some of this stuff just goes away, like we don't need to edit, we don't need to clean it up. You know, it's type safe. We can put what we want in there without worrying about, you know, getting the types wrong.
Does that mean that we don't have it anywhere inside of AudioKit anymore? Except for
no, it's still somewhere. I could have gone through more aggressively and got rid of it. I don't know.
Oh, the callback instruments. Yeah, it's one. I guess it's the only place. Just one last file that uses it. It's interesting. Sorry, that's a distraction.
I was just gonna say, I found that queue after, like, you know, a lot of the sort of, I feel like the recommended reading list for, you know, for thread safe, like real-time safe, that whole thing about like how to do shared memory with a real-time thread from the real-time 101 talks that I think you guys have mentioned here before. And I forget the two guys' names who did the 101 talks, but they're awesome talks. I mean, just crazy awesome stuff. But like they worked on this library called Farbot, and Farbot, I felt like they were in the middle of porting it when they made that video or something, and then they didn't finish it. But then I found this library, which seemed to kind of tick off like all the stuff that they were talking about for Farbot. And I found this library just like totally randomly, and I was like, this looks like a base to start from, at least for, you know, what I was working on, which was essentially doing something like this. So anyway, that's like the little bit of where I found that. Cool.
Yeah, it seems like a good one. I guess my only thing with it was that if you look here on, okay, so it's good to compare this, like line 101, 102. Before, what we were doing is a single call to this TP circular buffer tail, which basically tells us just, it looks at one of these atomic values that, sort of the way these things typically work. And I actually think the new one doesn't work this way, but I know how the old one works. And you kind of have a read head and a write head, and they're both like atomics, and they move along, and if they hit each other, then one has to, you know, then the like write head has to stop basically. But so when you call TP circular buffer tail, you're just reading one of those values, so that you're reading the read head, and a read pointer, whatever you want to call it, read index, you know. And so you can then go through a bunch of events at that point with only one atomic read. So if the main thread just sent you 100 things, main thread that sent you 1,000 things, you can just go and consume them all, and you've only done one atomic operation. Whereas in this new one, you're going to have 1,000 separate atomic operations because you keep calling try DQ. And I think for this, it's not really a problem because the main thread's not going to be bombarding the audio thread with stuff to do. But it's kind of something to be aware of. Every time you call one of these atomics, I think I even mentioned this last time, like the CPU does some sort of locking so that you know, like caches are coherent and all that stuff. So yeah, you can have a performance degradation from doing that. I noticed this really badly actually in my app, Audulus, which is a modular synth app, and I was trying to animate all the wires. So imagine you have just tons of wires going around a modular synth, and you want to animate them all. And I wanted to do it really nicely, you know, so I don't trigger thread sanitizer at all, you know, to be pissed at me. And
Taylor, I was watching videos of your app yesterday and thinking exactly about this issue. I was like, how is he doing this with all of that data from all the modulations? Anyway, sorry.
yeah. It's kind of it just breaks the rules basically, and just assumes that it just there's a little if def that just turns off thread sanitizer. Because what I noticed was that if I made it atomic and I was doing atomics for all that, then performance went down quite a bit. So I just kind of break the rules on that, which is fine to do if you just have a single value, really. Like if you're just reporting something in the UI, it's just going to be like a color of a light or something. It just doesn't matter to get it perfect, but if you're like I don't know, sending data to a file or something, you need to get that right. And obviously for this, you need to get your sequencer events, they need to be correct.
So the only thing I could think of that could mess this up would be there's some kind of sequencer control, like someone's changing a knob, and then we're automatically writing that into something that's looping, let's say a sequence loop, and we're suddenly ending up with a lot of instructions. But I don't even know if that's truly a lot, but it seems like a lot.
Yeah, I mean, if you're not doing too much else, then it's not that big of a problem. I think in my app, users are just always pushing it to the fucking limit. It's kind of can be, exhausting sometimes.
It's a
Trying to
compliment.
make it fast enough for what because it's this open-ended thing. They can just keep piling on more and more. But I think in most AudioKit apps, you kind of know what your parameters are. So I don't know. I mean, it might still be possible to have a performance issue, but
well, the interface here sure is simpler. Right.
Yeah.
I mean, the TP circular stuff was just brutal.
Yeah. It's TP circular buffer is like kind of old school C. It has its charm.
Isn't there like there's a subtle difference between a sort of like a FIFO queue and a circular buffer, right? Like a ring buffer. I don't know exactly what it is, but it's sort of like this one is like this concept of like we're queuing things, and the other one is like this. It's kind of like I feel like the ring buffer is sort of more like it's way closer to the sort of DSP usage stuff where it's like we're filling up like signal stuff because something has to read it out constantly versus like a queue is kind of like this idea of like this is the next one or this is the next one. I don't know if that's exactly right. But like
the semantics of TP circular buffer are really similar to the one in Boost. Like it just has like a finite size, it pre-allocates it. I mean, the kind of trick in TP circular buffer is some sort of like virtual memory mapping thing where.
Right, I read that.
Yeah, so like, you can call tail, for example, and you get a pointer. You see in line 106 here, you get a pointer, and you're thinking, well, that's interesting because, what if the events are wrapping around the end of the array? Well, they just like use memory mapping to create a duplicate image of it, so that it's sort of done twice, and that's a cool trick, I guess. I mean. But the thing is, you don't really need that if you have a nicer like type safe API like in Boost.
Well, I feel like it brings up this question of like this seems like something it's obviously going to be really complex for a lot of users or a lot of developers, right? And like I'm sure a lot of people would say, I don't even want to know what that does. I just want to be able to get the benefits of it, right? And partially, like I think about I'm trying to think of the name of it, but it's like some of the observer stuff when it comes to like the event processing around the DSP that Apple, trying to figure out to remember the names of the things, but it's like in the audio unit process functions is sort of like this thing that there's this piece of code that like interrupts the process calling and it processes events. There's sort of like this function called like process with one event or process with all events.
Right.
And I feel like that's sort of like their attempt to put something on top of something like this, because that attempt to sort of saying like, there was this thing you brought up of like, if you have a queue and some other thread just like piles all this stuff onto the queue, then you're only going to take one off per process cycle, right? Like the process function will call and you'll get the top one off, and that's that. But like the Apple way of dealing with it seemed to be like, that when some some kind of interrupt is happening and it's like, oh yeah, like get more events, and oh, are there more events, like then we'll have to call process again or something like this, and they seem to split up the process function. Is that right? I don't know.
I think what you're talking about the audio unit real-time events.
Right. Yeah.
Yeah. So those come in as a list that's given to you every time the process function's called. And
okay.
I think so. What it's doing is it's splitting up the process call so that the events are sample accurate.
Right. Okay. I see. So it's like going through the events and then.
Yeah. So like if you have, let's say you have a buffer of 256, frames, right?
Yeah.
And you got one event that it happens at frame 100 and one event that happens at frame 200. Then it's going to call your process once with the range 0 through 99, right? Then it's going to run then it's going to do whatever that event does, right? Then it's going to do the next interval. So that gives you, sample accurate.
Totally. That makes sense. I was thinking for some that it was like they were calling, it's somehow they were interrupting the processing of that process function. But now I get like it all comes
kind of is. I mean, it calls it little segments. It calls it little segments. So your process function needs to, I guess, be robust to that.
Yeah. And this situation here that you put into the sequencer seems like you could do something like that if you wanted to. You could say, okay, just go through at the beginning of process events, like give me everything. And that's what you're doing, right? Sort of like pulling all of them off and then figuring out.
It's while, it just consumes them all. It's line 102. It's a while loop while we can still do it.
Okay. Yeah.
Which
is pretty reasonable.
Yeah, I mean, and this should be very lightweight code that gets run here. So it seems like it'd be pretty hard to overload it, but yeah.
I guess when you put the new wavetable in, you could do this. You do the atomic try lock or whatever, where you say like, if this is the same thing, then just don't actually put a new one in. Like.
Oh, you mean like so you're talking about you're going back to the wavetable now, and you're saying like.
No, yeah, sorry, yeah, I forgot about.
If the wavetable. Yeah, we moved on to this sequencer here, but
right.
But
yeah.
Yeah, if the wavetable happens to be the same wavetable, then don't do anything. I guess, you could do that. You could checksum it or something, but I don't know. I would leave that more to the client, like to recognize, not to send redundant wavetables, I suppose.
I wonder if this is at all related to this issue about the sequencer not being able to play the notes at the same exact time appropriately. Because maybe I don't know if it fixes it or it might still be there, but maybe the idea here is that we weren't doing all events. We were just kind of getting the first event and then moving onwards, whereas now we're hopefully looping over all the events and getting all the node-ons.
I mean, I think it's doing the same thing basically as it did before. So, I don't know exactly what this bug is.
So if this is a real bug, it's probably still there, huh?
Probably still there.
I'll check it out. Okay. Actually, out of curiosity, I'd like to see this. So this callback has a MIDI buffer, or just this TP circular buffer, and how it seems like it would be fairly easy to clean up the new way if I just compare the two, see what you did with sequencer and try to do it here.
Yeah, easy. You could just use AU MIDI events and send them right across.
Oh, so not even use what you did on Secret Engineer, just kind of use AU MIDI events instead.
No, I mean you still would use the new queue. You would just put AU MIDI events in it.
Okay, because that would be cool, because then we could actually get rid of TP circular buffer and like kind of encourage people not to use it if it's not type safe, and puts novice programmers into a lot of positions of screwing themselves over.
Yeah, but I mean, novice program is using lock-free queues.
Yeah, I guess.
Any
At
kind
least,
of lock-free.
at least there will be like one type of thing that's used in AudioKit everywhere, so they can have the same thing to copy instead of saying two different options.
Yeah.
I just like to get rid of as much code as possible if I can.
I like to give that a shot. So I'll try to give some. I've been trying to find like some piece of contribution I could do code wise. So I don't know. I'd like to try to give that a shot and maybe put a PR up.
Oh, I'd love that.
But yeah.
You have that job.
Right, cool.
It's yours.
Thanks.
Thank you. Cool. Is that enough of it? You gave him enough of hints on what he should do? I think if you watch this video back,
I implemented this queue thing in a non framework based AU plugin where I was like loading sounds, like choose the sound, load an AV audio file, and then like have the data buffer come across into the real time zone and have it be safe and stuff. So I did that over there, so I can try to figure out what's going on with the callback instrument, which seems to be pretty straightforward. The callback instrument.
Yeah.
But anyway,
You'll have it done in 15 minutes, man.
Yeah. Okay. Sweet.
Translate that into non-Taylor time.
Yeah, it'll take me like an hour. I'm sure. I'll be like, oh, what's that thing? What's this other 7 things over here?
Well, I guess there's potentially some unforeseen stuff here, but I don't know. I think it's just sending little 3-byte MIDI events across.
Totally. Yeah. No, it's not crazy. It's not crazy at all.
Yeah, random thing that Taylor, I just bought your Audulus app. I thought I already bought it, but I went and checked it out. But yeah, I'm mind blown. Crazy.
It's weird because I've been working on version 4 for like ages now, and it's getting close. So it's just weird to me thinking about version 3, because you just bought version 3. So yeah, it's so old at this point.
Still amazing.
Oh, thanks.
Yeah, super cool app. Amazing. I don't know if there's another thing. I missed like maybe 10 minutes or something earlier, but I wanted to bring up the question of parameters, dynamically adding parameters. And I think like Audulus would do this kind of things. Like if you add a new oscillator, you add another oscillator. Mm-hmm. You're going to have parameters for each of those oscillators. And that was originally one of the things that kind of kept me from even digging in there. I think it might be like a year and a half ago or something. Like I was like, oh, I don't know about AudioKit. Seems like it's really great for these high level things, but I was like, I'm sort of like masochistic and I want to get into like shared memory on threads or whatever. So, but now it's like really in a great state to get into this stuff. But I'm like, how would you even go about, sort of creating a new, say, like DSP object or something in here? Because I noticed there's like a macro for like registering like parameters for plugin sort of DSP units. And I was like, what's going on with that sort of magical stuff there? I don't know if that's something you even want to touch, right now or whatever, but that's the thing I had to bring up. I wanted to bring up.
I have a +1 to that question, because if you look at the macro definition, I was like, we should be able to do that at runtime, right? It doesn't have to be at compile time. Right?
Well, it has something to do with like C and C++ and sort of like the, how that languages are being interpolated, I thought. Like, so you need to kind of do things in, I don't know though, but maybe you guys can tell me.
So
like how we got rid of Objective-C or something, right?
Yeah, I just want to say, first of all, that one of the office hours, either 1 or 2, we did build a from scratch. I don't know if you saw that one.
I think I did, yeah.
Yeah, and we covered like everything, but I think when we got to the part that was about the magic of what does AK register do, I don't think we went into that into a lot of detail. So I'd be happy to jump over here and talk about it. Actually, I'll be happy to jump over here and let Taylor talk about it.
All right. Well, yeah. Trying to remember why I put this in. There was some reason.
Honestly, I tried to take pieces of what you guys did to get rid of Objective-C and put it into something I was working on that was using it. And I was like, this is awesome. I got like kind of far, but didn't finish that piece. And I was like, okay, I'll get back to that. But yeah, anyway, I think I might be able to catch up and maybe add some stuff as if you can remember any of it. But yeah.
Yeah, I mean, this is using some pattern from C++, which is, I don't know exactly what you call it, maybe like static registration or something. That's, I don't know what I remember, but you create all these global objects, and it has to run constructors. C++ has to run the constructors for the globals. And so if you look at, I guess this, what is it? The DSP registration. Let's see, register creation function when initialized. Right. So here's the line 184 is that's its constructor. And so all these globals are created by the macros are just like a little bit of, sugar. So you don't have to like write this kind of long thing to create one of these registration objects. But it's basically creating a little global object that gets initialized as soon as the library is loaded. And then so as soon as the library is loaded, it initializes all this this lookup table that maps from names, strings, the names of the DSP objects, to some function that will build one. So it's kind of like a factory pattern, but it's distributed across source files. You don't have to like put everything in one central file. You just, if you're creating a new DSP thing over here, then you just add your AK register DSP and you're good to go.
And that's like, you're trying to basically create C functions that will call C++ functions, because those C functions are the ones that Swift can call. Is that right?
Yeah, ultimately, yeah. So if we go back and look at whatever the call is that creates DSP objects, that would be in here somewhere.
Right. There's a lot of like sort of AK something functions that are around,
yeah.
like all
you keep going up, Ari, it's probably it's in the C part of the file. Sorry, up. Okay, right. So AK create DSP, that. Let's look at the code for that. Okay, well, then that calls that. So here's where it says this little factory map. And it's gonna just call the construction function for that particular object. Yeah, so we're creating them all by name rather than having to, I don't know, have separate functions to create them all. I think didn't we used to have that, like separate functions, Ari?
We did. Yeah, we did.
The advantage of this is that you don't have to write any header stuff glue at all, potentially. If your DSP object is simple enough, if it just has like, a bunch of parameters, does its thing, doesn't need to like pass complex data across or anything, you don't need to write any glue headers. You just write your little C++ object, you use your little macros, and you're done. I mean, you don't even have to have a header file at all. You can do it all in a source file. In fact, isn't that how a lot of them are?
Right.
Almost all of them, yeah.
Yeah, we just got rid of all these headers because we use this.
Right.
So.
And that's for like creating the actual DSP, like you're saying, the small objects that go with your
kernel, the DSP kernel.
Yeah,
so,
right.
Yeah.
That's awesome. Yeah, I love that. But then how do parameters get involved in that? Like, how is that?
Yeah, well, it's a similar thing. I guess there's this parameter map.
Okay.
Yeah, so add parameter gets called by all those constructors. So not only
I see. So that create calls add parameter. Is that
no.
No.
What happens is
isn't that called from this stuff? Like
yeah,
when you do this?
When the library is loaded, then it's going to register all these constructors, and it's going to register the parameters on each thing. What this actually assumes is that all the parameter names are kind of globally unique, which is maybe not a good thing, but that's what it.
That's part of, for me, like if you wanted to create like multiple of your instrument or something like that, then that's, I felt like I was like, oh, how do I say, like, you know, cutoff for sampler one or synthesizer one, like, cutoff. That's the thing I got caught up on. So I was like, well, I don't know if Marcus was sort of looking for that too.
Well, because so internally to AudioKit, everything is nicely prefixed, you know, so like all the parameter names have the prefix is, if we go look at one of them. Yeah, you see how this is dynamic oscillator parameter frequency. It's not just frequency. So, but I guess this is a stumbling block in if one defines their own stuff, because maybe, you know, you're just being kind of quick and you're like, you've got two different oscillators, let's say, that's defined in your own code, and you put frequency in for both of them. If you don't, if those happen to be the different parameter addresses on each one, which is definitely possible, then it's going to break and you're not going to know why it broke. So we probably should try to fix that.
Well, that's like, say you have a dynamic oscillator and you want to have a plus button, and it's like dynamic oscillator, dynamic oscillator, dynamic. How do those parameters like work out?
Well, you mean actually, actually like have dynamic parameters?
Right. Yeah.
Yeah. I mean,
which I was like, I don't know if I should bring that up to you guys, because you know, I was like, if that's part of your plan.
Definitely, this system doesn't really support that. I mean, you could like, you know, there's nothing stopping you from making more parameters and kind of overriding things and stuff. You're just not going to get like the nice convenient way to do it if you wanted to do something that was really dynamic. Yeah.
I feel like this design pattern works really well when you're creating an audio unit, you know, wrapped in Swift, that inherits from DSP base. I feel like, you know, and that's a really common use case. That's like one of the powers of AudioKit is you have all these nodes, you have all these things, you put them all together at the Swift layer, and you get all this stuff for free. I feel if you're one of those people who are, what did you call it, like a masochist or a glutton for punishment, Matthew? If you really, you want to,
big dreamer, how's that? I don't know, you know, whatever.
If you want to create your own custom oscillator, then this stuff, it doesn't. This stuff takes away from boilerplate in that other use case, but it can add to the boilerplate in the use case where you want to create your own custom oscillator. Because then you're going to have node objects, you're going to have some generator that C++. You're going to wrap that at an audio unit level, and then in Swift, and then you're going to have UI. And you have to thread your way all the way through that.
Right.
Well, I don't think there's really, there's not that much around, there's no way to get around that, actually. Like, I don't think that and unless you're doing something really weird, like, are you Marcus, are you assuming that the client is doing something pretty strange so that they cannot use our boilerplate reduction stuff? Because that's what this is all about, actually. This is all about reducing boilerplate. I mean, we can't write audio units, the DSP code in Swift, so it has to call out to C, So.
Well, and again, that's why I made the point about the use cases. So if you're, putting together a dynamic oscillator, FM oscillator, morphing oscillator, filter, and you're hooking them up at the Swift layer, this certainly reduces boilerplate. This is a great solution.
Oh yeah.
If you're like, hey, I want to roll my own. Hey, I like Matt's dynamic oscillator. I want to roll my own. Then you just have more work to do as you're adding those new parameters to thread it all the way through, right? You know what I mean? So,
but what's the alternative, though?
If I had the alternative, I don't have an alternative. It's a point of discussion. Also, I think a valuable part of the discussion is how many folks have those use cases. If 5 people have this problem and 100 people are getting a benefit, well, then it's not a big problem.
Well, so the problem I was talking about earlier was just simply name clashes, and it's just like just something we can go and fix, I think, without too much trouble.
Mhm.
It's not
That's sort of like
By
like,
flagging
say,
a
like,
warning
line
or something.
well, actually, if you have that, well, actually, you know what? I think right now it will just abort and give you an error message if you try to register. You know what? Actually, I probably already solved this because it'll let you know. Sorry, this parameter's already been registered, and then you just pick a new name and you're good. So
Yeah.
maybe it was just worthless.
But this is like, yeah, sorry, I don't know if you guys are talking about that thing where you're creating 2 dynamic oscillators or 3 or 4, and it's a user choice. Because then is there like another part of the sort of the pathing? Like say Faust has this thing where it's a path to your thing, and it might be like oscillators, and you're like 0, 1, 2, and 3, and then the parameter names for those.
I feel like I'm introducing some confusion here. So let's pull back. So
I'll back off. Yeah.
it sounds like there's 3 different use cases that were brought up tonight. So mine was a new one that you weren't talking about. So the first use case is what we're all talking about. I made a dynamic oscillator. This is the pattern for it, and you can hook these nodes up at the Swift layer, and it's awesome. The pattern, the thing that you brought up was a new use case I never thought about before until you brought it up tonight, which was, hey, what if I roll my own oscillator and I want to add new parameters, dynamic parameters that aren't declared here at compile time. They're not here in the file. I don't usually do that. That's a new thing.
Mm-hmm.
I was coming up with yet another use case, which was, hey, I like this dynamic oscillator, but I also want to add things like I want it to be DSP and own a bunch of instances of a note, and I want to do note management, and basically I want to extend the scope of dynamic oscillators. So it's not even dynamic oscillator anymore. I'm gonna make a DSP that owns a bunch of note states, which are kind of atomic notes, manage polyphony, blah blah blah, and I have to thread parameters from this top layer down to those layers, and then also back up to the UI. And I didn't give a lot of context about that, so I totally get if that's really confusing. So yeah, we're talking about a lot of different things. So I think at this point we should probably, I should probably take mine back off the table because I don't have a good.
I just make sure I understand Matt Howell's thing properly. If you create more oscillators, it shouldn't matter that they're named the same thing because they're different instances of the oscillator. So you can should be able to still change the frequency, unless you're talking about like under putting them under one AU, in which case you're going to have to sort of have this wrapper AU that is going to say, okay, well, the knob on the DAW is changing this thing, but really internally that's going to be changing this oscillator's frequency. And so you're going to have this outer layer mapping it all.
Right.
There's really nothing we could do internally to deal with that situation, no matter what. I think you're stuck with that. I mean, I think we had that with Synth 1 as well. We have like hundreds of parameters on Synth 1. And inside, those have to get mapped to something that's inside of AudioKit, and it can be a mess. We have files that are like hundreds of lines long that are just sort of maps between AU land and DSP land and stuff. So,
okay, cool.
Yeah, I mean,
maybe that's like a much deeper thing, because that's I'm trying to understand more about that aspect of it, like where it's like exactly those things. Yeah, because I want to map, sort of, if you make you have like a 5-track thing and you're like, I want to put some instrument on each of them, you're kind of like, okay, so how do those parameters end up mapping back? And it kind of depends, like you're saying, on like what is it that wraps it. So yeah,
it's kind of a good problem to have, in a way that, before our AUv3s were all kind of stitched together and very clumsy. Now we should have a system that should fit in AUv3 land pretty well, but we haven't built any of the sort of wrapper code that would make life easier for AUv3 developers. And I'd like to do that. Just, it's a matter of finding the time and finding the project and all that. So, but yeah, I think if enough people are using AK5 to make AUv3s, we'll start to see emerging patterns that we could possibly rope back into the AudioKit itself, and make life easier for people.
Yeah, I just want to say this is a great group of people to talk about that kind of stuff. So I'm one of those people. want to make new instruments in AK5, and I want to extend, like dynamic oscillator is awesome, but I want to go add a bunch of stuff to it. So I want to make my own. So I'll be one of those people. So
Akiva?
I just wanted to add my 2 cents as someone who was using AUv3 just raw and then switched to AudioKit v5, and just how great it is to be able to like not have a separate framework and extension is such a huge boon. And we were using AudioKit v4 before, and there was almost a desire for AudioKit v5, the fact that we're using it inside of Swift Package Manager, that it almost just be something that makes writing AUv3 modules, just like writing those audio units is so easy in AudioKit v5. And it feels almost like that as its own package is of enormous value because of just the simplicity it provides to building new modules. And just, it's been so easy to just think in DSP and think about what we want to actually build and then put it in its own little folder, and you only have 2 files, and it's a dream. Yeah. So I was wondering, is there any desire to have there be almost like the AUv3 wrapping part of AudioKit be provided as its own project that can be also used with AudioKit v4? Because I think a lot of the audio session stuff that v4 provided is still very powerful.
I mean, honestly, probably not. It sounds like a good idea, but it doesn't seem like something that I'm not very motivated to do anything with v4, frankly. Like make it easier for people to use v4 at all. It is really nice to hear you say nice things about AudioKit 5, because we had a lot of people who got used to AudioKit v3, and I get all these complaints about like, oh, it's so confusing. And we try to tell them, before you had to create a header file and send something to the header file, that send something to an .mm file, and finally you got into DSP. There's so many more layers. So it's nice to hear that you find it simpler. My personality would be more like try to get people to make the entire change rather than coddle them to stay with what they were using before. But that's also because it's a lot of work supporting AudioKit, and I kind of want to, part of the mantra, or the reason why a lot of work was done in AudioKit 5 this summer, was to not have it be so hard to maintain, to make decisions that would make our lives easier. Have tests for everything, have break the ability for people to have broken signal chains, like force them to have signal chains that are valid from the get-go. These are choices that make us as developers' lives easier as well. So just trying to give you the motivation of why I'm saying no, that probably won't happen.
Oh, for sure. No, I understand that. I was just saying, like, the fact that v4 took care of so many things, and now there's a switch to kind of figuring every piece of that out. And I totally understand that switch. It's just, the fact that v5 makes it so easy to write your own audio units is, I think, the reason that everyone is going to switch to v5. Like, it's the only way to really make sense of building these audio units in a really simple way. And there's also the sort of cost of switching all of the other pieces that AudioKit did before and having to now take on that responsibility. So just thinking through it.
Yeah, I think with the Singleton audio engine being the hallmark problem with AudioKit 4, that supporting it is just doing a disservice long term to everyone. So.
No, I have a question to follow on with that, but I want to give other people.
Go ahead. My rant's over.
That there's a, what is it, the example, the AUv3 example app, I think, with Dash's repo. Is that 5 or is that 4?
That is 4. That was developed by Matt, or was like kind of open source by Matt and Jeff, and it supports all the recent LE apps that AudioKit Pro is coming out with and stuff. I really am trying to get everyone to switch over, but that's taking a bit longer.
So so I was looking through that last night, and I was like, this is great to look at. I have great things to say about that too. I love 5 a lot, but that one, I mean, when looking at that app, I was like, this makes more sense to me, whatever. So super clear. So anyway, when looking through it, it seemed like the big step for getting your, like, if you make a standalone app and you have some audio unit things in there, the main step for getting it into your AUv3 is to, sort of like, what is it? Use the manual rendering mode and then connect that into the sort of the extensions real-time threads. That's like the main step there, right? Like, am I wrong about that? Or is
No,
that
you're
just
not.
Sarah?
That's
Okay.
that's one of the big steps. Yeah.
Okay. I'm very interested in doing that too. So I don't know if Akiva, we could like work together or something. I don't know, whatever. I want to keep in touch with you because it's like this sort of, I'm very interested in that as well. So, but with 5, it's like bringing 5 to be able to do that simply, and so it didn't seem like you really needed that much from a framework in order to just add that into your project. So I don't know, but what do I know?
Yeah. So yeah, if you guys like my take on that, like, so AudioKit Pro has these apps that are standalones and they're AUv3, and there's all this code that some of it's being open source to make that work with AudioKit 4. My feeling is like a good model going forward, if we can, if anyone in this project is into doing it, would be that you basically focus on the AUv3 type environment. That is the core of what you're working on. And then your standalone is a very thin AudioKit provided, hopefully, wrapper around the AUv3. So you're kind of like, you're always in a host of some sort, whether that host is your own very thin layer or it's GarageBand, that's notwithstanding. So you kind of make sure it's working in the harder environment, which I think the working within a plugin is harder than working in standalone. If you can get it working there, and then your standalone is just a thin wrap around that, I think that would be a simple way for people to like get used to building apps that are both standalone and plugins. And that's a couple of projects are working on and trying to go that direction. But
I will say though that it can't be the only way, right? Because there are restrictions on what you can do inside plugins, and right, you still need to be able to make a standalone app that just uses, what is it, AV audio engine directly, or the AudioKit stuff on top of that. You know what I mean?
and you couldn't do that by basically have it be living inside your own version of a host?
No, because certain APIs, you can't call them from app extensions.
Okay, you mean like phoning home and like calling web stuff and things like that?
Well, you can't call NS application. You can't call anything on NS application, I think. Because you're not within an app.
It's all related to the sandboxing stuff, right? Is that like this, or like the
yeah,
extension?
I think so. I think so. But yeah, I mean, so I wouldn't want to put that constraint on people, even though it covers like most of the use cases really nicely. But it's just that one thing that you might need to do. I mean, I could dig a little bit and probably figure out what you can't do, which I'm guessing is.
What if you couldn't you alter the wrapper to do those things that have to be done at the wrapper level, and then make sure that all the audio stuff is inside of there? Like, so all the secret sauce that requires the app level, you just have to edit this wrapper to do that. I don't know. I guess this is more of one of those you have to try.
Well, I mean,
sort of like, yeah.
If you want,
all right, you're being really clear, and Taylor, you're being really reasonable.
sorry, what?
I feel like you guys are on the same page, but it's just like, because Ari is saying like you could deal with that if there is an extension-based limitation, then like you could figure it out and put it as part of your wrapper so that the stuff is external to the rest of the audio stuff, right? And then what you're saying is like, of course, you wouldn't want to put that limitation on anyone, like, on everybody rather.
Yeah. I mean,
I guess it's a worthwhile experiment. This is by no means a nerd fight between me and Taylor.
No.
We're on the same page.
I'm just like, I agree with both of you.
Get out my Nerf gun.
What'd you say, Taylor?
Gonna go get my Nerf gun.
Marcus, did you want to?
I was just saying +1 to what Matt was saying. I feel like you might possibly be saying the same thing and not realize it, but yeah, I feel like designing the audio stuff as a AUv3 and then whether AudioKit provides the host, that'd be great, or not, and having standalone specific logic be part of that, that host. It could be a really good design pattern. It's worth exploring. It's worth figuring out what you can and can't do.
Yeah, I mean, AudioKit 5 basically is a result of a lot of berating of me by Taylor about why this didn't work and that was not good. And so I'm used to it, and I actually react pretty well to changes that can improve things overall. So yeah.
I will say Ari is great about taking constructive criticism.
The Nerf gun scars are like apparent.
Yeah,
They're sexy. They're sexy, Ari.
Well, I get to take it out on Matt Pfeiffer after. Like it just kind of cascades down the line.
Yeah. All right. I feel like programmers are all about taking constructive criticism, or else you just get nowhere. You got to be able to take the blows at some point.
Yeah.
Well, this is a
great session.
Yeah, great session. This is a great assembly of talent and experience and stuff. So I thoroughly enjoyed. I learned a lot just hanging out with you guys.
Yeah, same. Before we wrap it up, and I know we're about to, Taylor, you mentioned that we can't do audio, we can't do DSP on the Swift layer. Have you ever heard of AV source node?
Yeah. I mean,
so can you actually do DSP on the Swift layer with that? Because I know I tried to make like a lookup table oscillator with it, and I'm totally naive about this stuff. So I have no idea if it's like a ridiculous thing to try to do, but it did work.
Yeah. I mean, I think my understanding is that basically Swift is a complicated language. You have to be pretty careful to avoid dynamic allocation. And a lot of things that you may not think would allocate will actually allocate, whereas in C++, it's more straightforward to understand what is and what is not going to allocate. So I don't know. I mean, if the Swift compiler gave you guarantees about what will and will not, then I think you could probably use Swift. And I even wanted to kind of touch on that earlier. Like, wouldn't it be great if we could just use Swift for everything? And I posted something on the Swift forum, the Apple's, Swift community forum or whatever it is, about real-time, doing real-time stuff in Swift, because that's what I would like to do ultimately. I would love to jettison all the C++. Yeah, I mean, some people just do it. I think they're just not very careful, and it's going to work most of the time. You probably could even allocate a few things on the audio thread, and I think we were just trying to be really, strict, and really by the book on this stuff. I think you can definitely like get away with it most of the time,
I think it's super important to be strict, Taylor, just especially for the use cases where people are assembling large graphs of all these individual components. I think.
Well, yeah, and they're also they're relying on your code, right? It's like one thing if I kind of make my own little app that, might do something wrong, but we're kind of making a foundation for potentially a lot of people, and so there's some responsibility there.
Yeah, so all I'd like to say about the source node is that, so we had, AudioKit playgrounds used to be a bigger deal because they were like the only examples AudioKit. Then it became too much a hassle keeping going, and we kind of moved to the cookbook. But there is this idea of the iPad playgrounds, and AudioKit has that. And but what it was a subset of AudioKit that was just the Swift files that interacted with Apple's DSP, so you could do like reverbs and stuff like that and access the microphone. But it would be kind of cool to inject some life into the iPad playgrounds by using AV Audio source node, which can be written in Swift and could be put in the playgrounds to do some fun stuff around there, but not for like a production app.
Does it just buffer way ahead of time, and then you don't need to worry about all this stuff? Is that what the source node does in order to get around, real-time issues?
I was looking through the docs while you guys talking. It doesn't seem like it gives you much insight into what makes it work or not work. I think it probably will just start to crackle if what you're trying to do inside is too slow.
Mm.
I don't think it's going to try to do anything too smart for you.
Mm.
But yeah, it would be kind of a fun project to see if we could maybe stick some of the cool Swift UI stuff that you're doing, Matt, into the playgrounds for iPad and bring some life back to that project, because I do miss the playgrounds, but I'm also kind of sick of them not working and having to deal with something that doesn't break on compiling. Like now with Cookbook and stuff, we make a change to AudioKit and it may not compile, whereas you can't really. I had to go through and like test each playground by running it, and that was too much work.
Yeah, I thought that 3D spectrogram was pretty cool.
Dude,
Nice.
Matt,
Thank
you're on
you.
a tear. You're on a tear, Matt. Like, keep going, dude. Don't stop.
Yeah, I get a kick out of it, so I'm glad you guys like it. I have fun.
It's gorgeous. I mean, anyone can use it. It's so cool.
Yeah, I'd like to make them really customizable too. Like my big thing is if I'm going to give them away, like I want to make it so that when people use it, they feel like they can make it fit their app. They're not just like, so cookie cutter about it, And so like the spectrogram, I feel like it should be able to go like any different direction, have whatever gradient you want. You should be able to like choose how many waves you want, that sort of stuff and that sort of like philosophy should apply to all of the views. I think they should all lend themselves to not all the AudioKit apps looking the same. That's what I want to try to avoid. So
Cool.
yeah.
Great. Well, that was a great session, and thanks for coming out. Is Saturday a better day for people? So we got a great group this time.
Works for me.
It's good for me.
I'm new though.
Maybe we'll switch to Saturdays then. Cool. I'll let you guys know on Twitter and on Slack. And if you guys are not on Slack, just hit me up and I'll add you.
I think everyone's there. Akiva, are you on Slack?
Yeah, I'm on Slack. I actually submitted the PR that messed up the playgrounds, I think. So that was me who was trying to update to the V5.
Okay.
Accountability. That's good.
No, I submitted that because the APIs had changed and I wanted to have at least the playground support the new API, even if they weren't really working all the way, because the sliders aren't implemented in V5. That was, I think, the big issue with the broken one. And I think I closed it and then I was like, is this okay? And I'm excited by V5. I think V5 is big, and I feel like the big thing, I mean, the fact that it makes creating those audio units is so huge that it justifies so much. I feel excited for focusing on AVAudioSession as like a separate problem, and I'm trying to figure out how to focus on that as some part of the AudioKit community, because I think that the simulator is great, but when things come to the phone, especially with like AirPods and stuff, that's where my head goes, is like, how can we make AudioKit V5 also think about audio sessions as like a separate concern that people can learn about, because it's so hard to learn about what's happening with audio sessions on iPads and iPhones. So I was just going to add that as like a last final thought of if there's some way to make audio sessions something that we can focus on.
Yeah, also anyone wants to do some screen share or some pair programming, a couple hours or whatever on some projects, just hit me up. I'm usually around to do this sort of thing. It gets me motivated to keep going too. Cool. All right. I'll stop recording now. Bye.
Folks.
See you guys later.
Toodles.